Hello everyone, welcome back to the lecture series of automotive manufacturing process and technology. Here, last time we had discussed in lecture number 3, we had started the topic of drawing, and we had seen uh, that your drawing has been basically classified into basic categories. So first is sheet metal drawing, and second one is bar wire drawing. Okay, so we had already seen sheet metal drawing is further classified into two categories, that is the shallow drawing and deep drawing. If your diameter by height ratio is less than half, that is what is called as your shallow drawing, and if it is more, then it is called as your deep draw. Now moving ahead, the second category, that is the wire bar and tube drawing. In this, again, the same thing happens. There will be reduction in the cross section will be taking place. Okay. And this will happen that from on the one side, your actual workpiece has been inserted, and on the other side it is been pulled with the help of force. That's what the actual definition of the drawing is. Okay. So in a bar and your wire drawing, it is basically a deformation process in which the workpiece is in the form of cylindrical bar or the rod. Okay. In the previous method, in the sheet metal drawing process, you are using the sheet blanks, and that's why it is called a sheet metal drawing process. But here, in your bar or wire drawing, you will be using either a cylindrical bar or the rod, and it will be passed through a die, which will be a converging die. The stress which will be applied is a tensile stress, and then a force will be there. It will pull your workpiece through that die. Okay. The material is subjected to compressive stress within the die, thereby deforming it plastically. Okay, so from here, as the tensile stress will be applied, but in the internal side of the die, you will be available with the compressive stress also. Okay, because the die is a converging die. Okay. So drawn rods, let us say if you are using a rods, they will help you out in making bolts. Wire will help you out in making electrical wires, cables, strings, electrodes, and all. The basic difference between your wire drawing and the bar drawing is that the size of the bar stock used for bar is large for the bar drawing. Okay, whereas for the wire drawing it is smaller in the diameter. Okay, because you can understand the diameter of the bar and the wire, both are totally different. So for the bar stock, a very large diameter is required, whereas for the wire, thin or small diameter is required. Apart from that, the basic difference also lies that when you are going for a wire drawing, nearly 4 to 12 dies are used. That means consequently, your wire or your this bar should be passed through 4 to 12 dies, because a big diameter is to be converted to a very thin wire. Okay, so obviously gradually you need to reduce the diameter, and that is done with the help of different number of dies. Okay. Whereas bar, when you are going for a bar drawing, it is done in a single draft. Okay, now draft means it is just a basic difference between the final and the initial diameters. Okay, that is, here you can see this diameter is different and this diameter is different. So this difference is called as the draft. So in one go, it will be done for bar drawing, whereas it will take 4 to 12 dies or 4 to 12 passes, you can say, for your wire drawing. So wire drawing is a continuous process, whereas bar drawing, you can do it in a single step. So this is what the setup of bar drawing. Here you can see there will be a complete bench will be required. Okay. So rod or bar drawing, there is a draw bench. This whole setup is called as the draw bench. There will be long table available to us in this draw bench. Okay. There will be a die stand. Here you can see this is the die stand available here, in which you will be available with the dies, converging dies. There will be a carriage used to grip and draw. This is what is the carriage. It will grip your workpiece and it will pull it. Okay, it will pull it through these converging dies. So here you can see this. These are your workpieces. The workpieces are passing through these dies, and the pulling is taking place with the help of carriage. And this carriage is moving with the help of a hydraulic cylinder. Okay. So die stand may contain one or two molds. Here there are two different molds are available to us. so that you can convert, or you can draw two or more bars. Okay, so if let us say you can occupy three, depending on the size of your bench, you can have three, you can have four, depending on the size of your bench. Okay. So drawn bench is very, it can go up to 100 feet in the length, okay, depending on your requirement. The force which is required to pull, okay, which is required to pull the carriage assembly, it can be provided with the help of a hydraulic cylinder, or you can have a mechanical setup also where a chain pulling is been done. Okay, and the pulling force can be as high as 150 tons, okay, for industrial purposes. Next is your wire drawing. Wire drawing is basically a generation of wire. We have already seen that nearly 4 to 12 passes you may require, or more number of passes, whereas bar drawing is done in a single draft. So wire drawing is a continuous process, and the conical dies are used, which may be available with the angle of 8 to 24 degrees. Okay. Now there will be a continuous rubbing because it is a continuous process. So there will be continuous rubbing will be available. Your dies will wear out very much faster. So different hard materials are used for die manufacturing, and these are those the names of those materials which are used for die manufacturing. So you can use alloy steel, tungsten carbide for manufacturing of your dies with the included angle of 8 to 24 degrees. Now there will be a 25 to 30% reduction in cross-sectional area in one pass. You can achieve only 25 to 30% of cross-sectional area. Okay, so that's the one more reason why you need to pass it through various number of dies, because in one pass, on one one time of passing, only 25 to 30% reduction is there, and hence it has to pass through various number of dies progressively. Okay, progressively means after one by one by one by one. Okay, so that reduction will achieve. So here you can see this is the die. Okay, this is the part which you need to pull. Okay, this is the force which has been applied, this is the wire which is going. So this angle is uh, you can see the included angle, which can be 8 to 24 degrees. Okay, so during this many number of passes, the plastic deformation will happen. Okay, and this is basically a cold working. Okay, here cold working is going on, so there will be strain hardening will taking place. Okay, so strength increases and capacity to go undergo plastic deformation decreases. Okay, why this point arises? Because it is a cold working process and strain hardening has taken place. Excuse me. Therefore, during the entire run of the wire, it has to be heated. Therefore, during the entire run of the wire, it has to be heated, okay, and cooled at regular intervals to remove the effect of work hardening. Okay. So once during the initial in the first lecture, we had already discussed that if you need to remove the effect of strain hardening, then you can go for annealing process. Similar to that, here as the cold working is taking place, so obviously the strain hardening effect will go on increasing, because your this thing has to pass through various number of dies. So that strain hardening should not take place beyond certain limit. So that's the process. That's the reason why you need to remove the effect of work hardening. And this process is called as in-process annealing. Okay. So what happens is uh, you need to have a continuous lubrication box is there. Okay. Annealing station is available to us. If you see the right side of the diagram, there is one annealing station is also available. Okay. A This is one annealing station, this is second annealing station, this third annealing station. Okay, so these annealing stations will help you out to remove this plastic deformation. So similar to the previous drawing method, you can clean your workpiece, okay, by acidic bath or by different methods. Okay, apart from that, the front end has to tapered. It has to be tapered so that the front end may start entering in the die properly, because your die is a convergible die, so the diameter cross section area will be less here. So the front end can be tapered so that the insertion can be easy. During the wire drawing, heat is being generated during because of the friction process, okay, between your wire rod and the die. Okay. And that's the reason why you can means friction is generated, then obviously heat it will be there, and this will wear off your die material, and there are chances that your actual wire may also get wear off. So to overcome this drawback, you can use either dry soap. You can allow your wire to pass through the dry soap, or you can use synthetic lubricant. Okay. So dry soap will reduce the friction. It will not allow you to generate the heat, or you can go for water cooling dyes. Okay. You can cool your wire afterwards also, or you can use the water cooling dyes so that it will reduce the temperature which is generated because of the friction force. Okay. There are few major variables for your wire drawing which you need to take care. The first one is what is the reduction ratio, the reduction area. Okay. The second one is your die. Yeah, this die. Then the third one is your friction. Okay. So here